Welcome to this explainer. Today, we're going to explore what is honestly a monumental shift in how we use technology. Now, for the past few years, we've all watched artificial intelligence evolve at this crazy rapid pace, right? We've seen it go from a simple chatbot that can, write a polite email for you to something far more ambitious. Well, today we're looking at some absolutely fascinating research out of Nanyang Technological University that's attempting to turn AI into an autonomous scientific inventor. We're literally talking about moving from AI as just a helpful assistant to AI as a genuine brainstorming partner in the lab.
So, let's dive right into this big question. Because right now, asking a standard AI model to brainstorm novel research often feels a bit like listening to a broken record. Seriously, if you've ever tried to prompt an AI for fresh, groundbreaking ideas, you've probably noticed that it gives you something pretty plausible the first time. But if you ask it for, say, 10 more ideas, it kind of just remixes that exact same first thought over and over again. It totally lacks that divergent, outside-the-box thinking that human researchers naturally bring to the table.
Section 1. AI's narrow brainstorming problem. To understand why AI struggles so much with real, open-ended scientific discovery, we first have to look at this concept that researchers call conceptual collapse. In a real-world scientific workflow, the value of an AI isn't just in generating a single, safe proposal. A human researcher wants a diverse menu of independent, sound, and non-obvious directions to pursue. But when current AI models try to generate multiple ideas, they just quickly collapse back into really familiar, safe territories. They cluster tightly around existing literature rather than actually branching out into the unknown. And this brings us to the core limitation of existing systems. They basically force a choice between quality and diversity. They usually optimize for one or the other. If you push an AI purely for diversity, it starts hallucinating wildly, generating ideas that are entirely unsound or mathematically flawed just for the sake of being different. On the flip side, if you optimize purely for quality, you get the exact same safe, trivial idea rephrased 5 different ways. It's an incredibly frustrating dilemma for scientists who absolutely need both.
Section 2. Meet the multi-agent team. To solve this dilemma, researchers introduced a brilliant framework called IDEAgent. Instead of relying on one massive AI brain to just do everything at once, we can think of IDEAgent as a highly structured digital team of scientists working together in a virtual lab. By breaking down the complex task of ideation into very specific roles, they've created a system that actively manages both quality and diversity at the exact same time. Let's actually meet the team members who make this happen.
First up, we have the ideator. You can think of this agent as the eager brainstormer of the group. Its sole job is to read a huge corpus of background papers and generate the initial raw seed ideas entirely from scratch. It doesn't worry about perfect formatting or anything like that. It just focuses on finding a gap in the literature and proposing a potential intervention or new mechanism.
Next, we have the stenographer. Because let's be honest, the ideator's drafts can be pretty messy and unstructured. So the stenographer steps in to clean things up. Its job is to take those loose drafts and summarize them into a very strict, concise structure. It extracts the core problem, the central mechanism, the novel value addition, the key assumptions, and the expected effect. This structure is absolutely vital because it makes comparing different ideas mathematically and logically possible later on.
Then, those beautifully structured ideas face the harsh reality of the judges. And this isn't just one simple check, it's a multi-dimensional gauntlet. First, there's a quality evaluator checking for clarity and non-obviousness on a strict 0 to 100 scale. Then, there's a soundness panel made up of 5 independent judges hunting for any logical or mathematical flaws. And finally, there's a diversity judge who explicitly compares the new idea against historical archives to ensure it isn't just a sneaky, reworded copy of a previous attempt.
So, looking at the complete lab roster, you can really see how this structured pipeline operates, culminating with our final, crucial member, the critic. The critic is the bridge that makes this whole system iterative and smart. It takes all those harsh numerical scores and failure evidence from the judges and translates them into really focused, actionable feedback. It doesn't write the new idea for them, it just tells the ideator exactly where the logic fell apart or why the idea wasn't novel enough, prompting the ideator to try again and do better.
Section 3. The evolution of an idea. The really crucial point here is understanding how this digital team actually processes a concept. They don't just generate a list and call it a day. They treat ideation almost like a biological lineage. Just like in nature, ideas in this framework mutate, they improve, or they die out. If an idea is a close variant of a previous one, it shares the same lineage and isn't counted as a new discovery. This mechanism literally forces the system to evolve its thinking rather than just spinning its wheels in the same spot. Every single idea goes through 3 distinct stages. Stage 1 is generate and assess, where the seed is born and judged. Stage 2 is route and repair. Now this is cool. If an idea fails the quality gates by just a narrow margin, say it's really novel but has a tiny logical flaw, it gets a one-chance repair ticket. It's sent back to the ideator with that targeted feedback we talked about. Finally, stage 3 is refine. If an idea actually passes the strict gates, it still gets refined to polish its clarity and impact, making a merely good idea truly great.
Stepping back to look at the full architecture, IDEAgent meticulously manages its memory. It maintains distinct archives, an active archive for the winning ideas and a historical archive for replaced or displaced ideas. But instead of storing massive, bulky text files of every single bad idea, it stores compact signatures of failed patterns. This forms a lightweight memory of dead ends to avoid, ensuring the AI is constantly pushed out into unexplored design space.
Section 4. Measuring success with yield. Okay, so this all sounds incredible in theory, right? A fully automated lab of digital scientists. But how do we actually know if this framework works better than just asking a normal state-of-the-art AI to give us 10 good ideas? Well, independently measuring quality or diversity is super easy to game. So the researchers had to invent an entirely new way to score success. They created a joint metric, and they called it yield. Yield looks at a generated set of ideas and extracts the largest possible group where every single idea passes strict quality thresholds, meaning they are sound, they're clear, they're non-obvious, and every idea is distinctly different from the others in the group. This perfectly mirrors reality. As a human researcher, you don't just want one good idea, and you definitely don't want 10 variations of the exact same idea. You want a menu of brilliant, diverse, and viable paths.
Section 5. The future of discovery. To put this whole thing to the test, the researchers evaluated IDEAgent against baselines across 32 distinct research topics spanning 8 different domains of computer science. We're talking everything from AI to robotics. The models powering these agents were state-of-the-art, with the ideator driven by highly capable language models and independent external AI judges acting as the final jury. The results they found were absolutely staggering.
When looking at ideas that required a very high threshold for non-obviousness, IDEAgent outperformed the best competing baseline system by a massive 3.89 times on the yield metric. I mean, think about that. It wasn't just slightly better, it was nearly quadrupling the output of usable, high-quality, diverse scientific ideas using the exact same ideation budget.
But what is really interesting here is the consistency. Under moderate quality thresholds, the best baseline system could only generate at least one viable idea in 25 out of the 32 topics. IDEAgent, on the other hand, successfully generated viable ideas for 31 out of the 32 topics. It proves that this multi-agent iterative approach rarely hits a dead end. It almost always finds a valid, novel research direction, regardless of whatever scientific domain it's dropped into.
So why exactly does this system work so much better? Well, the researchers analyzed the data from the individual steps and found something fascinating about the repair phase. When an idea was sent back for repair because it narrowly missed the mark, the targeted feedback primarily fixed logical inconsistencies. In fact, the repair phase boosted the soundness of those promising ideas to nearly a 100% qualification rate. It was literally pulling brilliant but flawed concepts across the finish line without sacrificing any of their novelty.
Which leaves us with this final thought to take away. We are undoubtedly crossing a threshold here. As AI frameworks like IDEAgent master the art of generating a diverse, high-quality menu of research ideas, the human role in science is about to fundamentally transform. If the machine can brainstorm, critique, and refine the hypotheses of tomorrow, our job is no longer just finding the ideas, it's deciding which of these brilliant machine-generated paths will best shape the future of our world. Thank you so much for joining me on this explainer, and keep questioning what's possible.